Okay, let's get started.
Good morning, Ms. Burton.
Good morning, Charlize.
I do.
All right, so we are going to talk today about something called the Hinge theorem. And the Hinge theorem says if you have two triangles that have two congruent legs, so in this triangle, BC is congruent to DF, and BA is congruent to ED, all right? That says, the Hinge theorem says, the other leg, if the angles are not congruent, that the other leg that is opposite the angle, whichever angle is bigger, the bigger leg is opposite that angle. So in this case, this is a 90-degree angle, and this one is only a 60-degree angle. So that means that which one is bigger, AC or EF? AC is bigger. Why? Because it's across from the 90-degree angle. So you can say that AC is greater than EF. Can you tell me what AC or EF are? Like, do you know what their measure is? No, but you can compare them. So you can say that AC is bigger than EF because it's across from the larger angle. Is there another way you could write this? EF is less than AC. All right, either one of those would work. So again, this works, this Hinge theorem applies if your two sides are congruent, but the angles are different. Okay, the two sides are congruent, but the angles are different. So for example, in the Hinge theorem, we also then have the converse of the Hinge theorem. What does converse mean? Flip it. So if the Hinge theorem says, so in our example previously, if it said the one across from the bigger angle is the bigger side, what do you think the converse says?
The one across from the bigger angle.
Bigger. One has the bigger side, then that has the bigger angle. Good. So in this case, which angle would be bigger, B or D? B would have to be bigger. Why? Because this side is bigger. This side is 14, so B is across from that side, and this side is 12, so D is across from that side. So in this case, angle B has to be bigger than angle D. Again, what does the converse mean? It just flips it. The converse just flips it. So in this case, the converse says if you have the side, you can figure out which angle is bigger. Does it tell you anything about how big B and D actually are? No, it just allows you to compare the two. All right, so the Hinge theorem just lets you compare the two. Okay. So we can use that then to write inequalities. And we already wrote inequalities just comparing the sides. We're going to look at some problems that have a little more algebra in them, and we're going to set up inequalities that way. So that's what we're going to look at next. All right, this is just written out for you so you can see it. Okay, so what can we mark as congruent in these triangles? In triangle QPS and triangle QRS, what can we mark as congruent? Charlize? QS is congruent to QS. How do you know that? Reflexive property. Okay, the reflexive property lets you say QS is equal to QS. All right, and then what else is congruent, Tiara? PQ is congruent to QR. Okay, so in this case, I want to figure out which is bigger, angle PQS, which is this one, or angle RQS, which is this one. So how can you figure out which one of those is bigger, angle PQS or RQS? Which one would have to be bigger? PQS has to be bigger. Why? Because it's across from the bigger side. All right, so PQS is bigger, which means my alligator is going to be facing PQS. All right, so that's a greater than sign because it's trying to eat PQS because PQS is bigger. So is this the Hinge theorem or is this the converse? This is the converse of the Hinge theorem. Why? Because it gave you the sides and you're looking for the angles. So it gave you the sides, you're looking for the angles. All right, down here, is this going to be the Hinge theorem or the converse? This will be Hinge because it's giving you angles. What sides can you mark as congruent down here in this parallelogram? What sides? LK and MN, I don't know that those are congruent. I know that LM is congruent to KN, and what else do I know? LN is congruent to LN. Okay, so then which one is bigger, KL or MN? Why is MN bigger? This angle is 57, so that's bigger than 53. So MN has to be bigger. So which way does what do I put, a less than or a greater than sign? It is a less than sign because MN is the bigger angle. All right, what do you do if there's algebra in there? What do you do if there's algebra in there? I don't want to say it equals to that because I don't know that they're equal. But hang on, before we do that, what do we know is congruent? TV is congruent to TV, and I also have UV and VW. So now I know that which of these is bigger? 45 is bigger. Why? 25 is greater than 24, so that means this angle right here has to be bigger than this angle. So what inequality could I write? 45 is greater than 6z minus 3. Now what do I do? It's like a normal algebra problem, except instead of an equal sign, we have an inequality. You don't do anything differently. The only difference is if you multiply or divide by a negative, what happens? Flip the sign. All right, but other than that, everything is exactly the same. So what do I do first? Plus 3.
It's kind of like when you did in the previous test a while back.
Yeah. All right, so this gives me 48, which is greater than 6z. And then how do I finish? Divide by 6. Since I'm dividing by a positive, nothing changes, so I just divide by a positive, and I end up with what? 8. So that means this says what? 8 is greater than z, which means z is less than 8. All right, either of these is correct. I don't care which one you write. This one, I think, down here, this bottom one, just makes it more obvious what z could actually be. So give me some values of what z could actually be. 5, 6, 7. It's just like what we did before when I would say, like, give 3 values for z when we were doing, what were we doing then? Oh, the sides of a triangle. All right. So if I just ask you for the inequality, you can leave it right here. If I ask you for a range of values, you would figure out 3 values that it could be or however many I ask for. I'm not usually going to ask for more than 3. Okay? And again, how did we know that 45 had to be bigger than 6z minus 3? Because the 25 is bigger than the 24. So the Hinge theorem tells you if two sides are congruent. Could you have done this if you didn't know that these two sides and these two sides were congruent? No. All right, to use the Hinge theorem, you have to have two congruent sides. Gabe?
On the board it says find the range of values for z. What would you put for that?
So that's just this, right here. Unless I say give me 3 values for z, if it's just the range, this is the range right here. Because this tells me all the stuff z could be. You assume that I know what that means. That might be assuming a lot, but you can assume that I know what this means. Okay, do these on your boards. Okay. Hasn't been that long, still good morning. All right, good morning, Miguel. All right, how do I do number 12?
So since,
Yeah.
Okay, so since 38 is bigger than 30, you're going to do 12x minus 7 is greater than 3x plus.
Okay, and then what?
Subtract 3x to 12x,
Minus 3x minus 3x.
which you get your 9x minus 7 is greater than 2. And then you add 7. And then 9x is greater than 9. And then x is greater than 1.
So x is greater than 1. Perfect. Okay, so give me 3 values that x could be. 2, 3, 4, 5, 6, 7, a million, 2 million, 3 million. Okay, any of those, anything bigger than 1. Right, x could be anything bigger than 1. So we're going to look at a 2-column proof using the Hinge theorem. So here's just an example. All right, given that KL is congruent to NL, so KL is congruent to NL. What? It might be easier to do what? Why? How?
Because they're overlapping.
Okay, so I'm looking at that, and it's really hard for me to see anything, right? So Gabriel's suggestion is to redraw them as separate triangles. I think that's a good idea because that allows you to see a little bit more. So what I'm going to do is I'm going to move all this stuff down, hopefully. Oh, that's all one thing. All right. Okay. All right, so if I redraw those triangles, what are the two triangles that I'm looking at? KLM, and then what other one? LMN. So that's right here. So then what's this letter? L, M, N. All right, and this tells us what? We know that KL is congruent to LN. All right, is there anything else that you know is congruent? LM and LM. Because of what? Because of the reflexive property. So in that, we already know now that two of the sides are congruent. Is that easier to see when you draw them separately? Yeah, I thought that it looks, when you look at this, it looks like three separate triangles, right? So you want to figure out when you're approaching a two-column proof like this, you want to figure out what's going to be the easiest way to see it. And I think this gets easier if you separate them. Because now you know that LM and LM are congruent using the reflexive property. That's down in your slide. All this stuff is written, so don't worry about copying all that down. All right, what else then are you looking at? I want to prove what? KM is bigger than NM. All right, how can I do that? Yeah, which angles do I care about then? If I'm doing KM, I care about angle L. And if I'm doing NM, I care about angle L also. Huh. KLP plus PLM equals what? KLM. Okay. So is this MN across from that whole angle L? No. Which one is it really across from? It's really across from MLN, this one right here, right? So it's not across from the whole thing. So if this angle, KLM, is this whole angle, and this angle, MLN, is just this, which one has to be bigger? The whole angle has to be bigger. So KLM must be a bigger angle than NLM. It has to be, because NLM is just a part of angle, this KLM angle. Does that make sense? No? Okay, so it's pretty confusing, right? So take a look at this right here. I'm going to erase what I already drew. All right. Which angle is NM across from? What's it opposite from? Angle MLN or NLM. So this one right here, this little one inside there, right? Do you guys see that? In this triangle, it's across from NLM. Okay, KL, or I'm sorry, yeah, KL is across from which angle? Oh, I'm sorry, KM. KM is across from which angle? KLM, which is this whole thing right here. Do you guys see that? So KM is across from this whole angle. So then which one has to be bigger? KLM. Why? Yeah, it includes this little one and then also some more. So it cannot be smaller than this angle right in here. This one has to be smaller. So that means which side has to be longer? KM has to be longer. So I'm going to put the proof back up here. Maybe. Okay. So if KL is congruent to LN, if KL is congruent to LN, and LM and LM have to be congruent, because we said based on the reflexive property, those have to be congruent to itself. All right, then I say KLM, this big angle, is what? KLM is equal to what? This little angle plus what? KLN, this bigger angle right here. And that's based on the angle addition postulate, which is a complicated way of saying what? The angle addition postulate just means what? If you add two angles, it equals the bigger angle, right? So then I can say that KLM has to be bigger than NLM. Why? Don't worry about the comparison property of inequalities. Just explain to me why KLM, the whole angle, has to be bigger than the little one, in your own words. It includes both, right? So if it includes the littler one and then also some more stuff, it must be bigger, okay? And that's just the comparison property of inequalities. You guys can explain that in your own words, though. You can say, like, if it includes the whole thing, then it would have to be bigger. Yeah, that's fine. You can always do that on a two-column proof. If you can't remember the theorem name, just explain it in your own words, all right? And your own words should not be definition of congruent, because it's never that, all right? Okay, so then the last thing, now that we know that this angle is the bigger angle, what can you say about KM? It has to be bigger than NM. NM. Has to be bigger than NM, based on the Hinge theorem. Okay, I want you guys to try one of these at your boards.